Hi, welcome. We are going to talk today about addition rules of probability. Um, and let's ask some questions here. What are the chances of flipping a coin and it landing on heads? Write your answer as a percentage, decimal, and fraction. I'm going to change the order there. If you're throwing a coin, flipping a coin, and it landing on heads, since there's only one head on a fair coin, we call it a fair coin because if you had a coin with two heads, that would not be fair. Um, would be 1 out of 2. And then you can do the division. Just take 1 divided by 2, you get 0.5, and then convert that to a percentage, which would be 50%. What are the chances of rolling a fair six-sided die and getting 6? Write your answer as a percentage, decimal, and fraction. Once again, there's only one 6 on a fair six-sided die, and so that would be one number 6 out of 6 different outcomes. And if we write that as a decimal, that's 0.166666666 repeating. So we'll say that's approximately equal to a 0.17. And that would be then approximately also equal to 17%. All right, so the probability is the proportion of times a particular outcome will occur in a long series of repetitions of a chance process. If you flip a coin a lot of times, you'd expect about half of the flips to land on heads. If you roll a die lots of times, you expect about 1/6 of the rolls to land on 6. In probability notation, the probability of an event A can be written as P parentheses capital A. That's the probability of A happening. It's just a faster way of writing the probability of a given event. Probabilities are most often written as fractions using this formula. The probability of A is equal to the total number of favorable outcomes, the outcomes in the category of interest, divided by the total number of possible outcomes. Let's do some examples here. We want to give your answers as fraction, decimals, and percentages. You have a bag of 20 marbles. 7 are yellow, 7 are blue, and the rest are red. So what is the probability of drawing a red marble? We write that as P parentheses red. The probability of drawing a red. Since there are, let's see, 7 yellow, 5 blue, we can add that together and say that that's 7 plus 5 is 12. And since there are 20 and the rest are red, we can write that 20 minus 12 is 8. And so the number of red marbles is 8. That's the total number of favorable outcomes is 8 out of the total of 20 different outcomes. We want to simplify it if we can, and 4 goes into both 8 and 20. 4 goes into 8 2 times, 4 goes into 20 5 times. And so that's 2/5, which if we write that as a decimal, that's 0.4, and that would be 40%. And so those are our answers in both fractions, decimals, and percents. Sometimes we're interested in finding OR probabilities. You'll win a game if you roll a 5 or a 6, but lose if you roll a 1 through 4. What's the probability that you win? So it says write the sample space of this chance process. You're rolling a die. You have six possibilities. The 6 possibilities being 1, 2, 3, 4, 5, or 6, which is a total of 6 possibilities. How many possible outcomes are there? 6. How many outcomes result in your winning? Well, you win if you roll a 5 or a 6, and so the possible outcomes would be 2. And so the probability that we would win would be 2 out of 6, which once again simplifies to 1/3. As a decimal, that's 0.33, et cetera, et cetera, et cetera. Repeating, it's a periodic decimal, and then that's approximately equal to 33%. And we should technically write these as approximately equal. Okay, let's look at a more complex situation. You're playing a game where you have to roll 2 dice. If the dice add up to 8 or 11, you win. If they add up to anything else, you'll lose. What is the probability that you'll lose? Write the sample space of this chance process. Okay, once again, here you're rolling 2 dice. And so we could write 1, 1. Let's write them in here. We'll write 1, 1 to represent that we've got, that's one outcome is a 1 on the one die and 1 on the other, or a 1 and a 2 and a 1 and a 3 and so on. And there's this, it will go on and on until you get to 6 and a 6. And that would be a total of 36 possible outcomes. How many outcomes result in your losing? If they add up to an 8 or 11, you win. Now, so this is a little bit trickier. So we'd say how many die roll add up to 8 or 11. So if you think about, let's add up the total for 8. If one of the die is a 1, the biggest the other one can be is a 6, and that would be 7. So the cannot be a 1. It could be a 2 and a 6, which would also be, so that would also be the same as a 6 and a 2. It could be a 3 and a 5, which would also be the same as a 5 and a 3. We could have a 4 and a 4, which again would be this. There's only 1 4 and 4. 5 and a 3 we've got. Those are all of the ones that add to 8. So now the ones that add to 11, if you have anything smaller than a 5, like if you have a 4, the biggest one that could be on the other if one of yours is a 4, the biggest the other one can be is a 6, so that would be 10. That's not adding to 11. So 4 doesn't work. It has to be 5 and 6 or 6 and 5. And so I think here there's 1, 2, 3, 4, 5, 6, 7. If there are 7 ways to win, because there are 36 total, that means there are 29 ways to lose. And so the probability that you would lose would be 29. Now, this is kind of tricky because it says favorable outcomes. Obviously, it's more favorable for me to win, but favorable in this instance is talking about what are the ways that since the question being asked is, what is the probability that you lose? The favorable number of outcomes is how many ways you can lose. So that would be 29 out of 36. And then you can convert that to a decimal and a percentage. All right. Probabilities are at least 0. No less than 0. You can't have a negative probability. Probabilities are less than or equal to 1. The probability of the complement of A is equal to 1 minus the probability of A. Is it possible to flip a coin and get a heads and tails at the same time? No. Is it possible to roll 2 dice and get a 1 and a 3 at the same time? Yes. Unless you're talking about the sum. You can't get a 1 as a sum. So I'm assuming a 1 on one die and a 3 on the other. Yes, that's possible. Mutually exclusive events. Events that cannot occur at the same time. In other words, the probability of A and B happening together is equal to 0. Examples. State whether these events are mutually exclusive or not. Driving east and driving west. You're either doing one or the other. So, yes. Sleeping and breathing. You can be sleeping and breathing at the same time, so that would be no. Drawing a red card and a queen from a regular deck of cards. In a regular deck of cards, there are 2 blacks and 2 reds from each suit, meaning you can have 2 red queens or 2 black queens. And so these are not mutually exclusive because they can both occur at the same time. You can have a red queen. Waking up late and getting to class on time. You can wake up late and skip breakfast and still get to class on time. So these are not mutually exclusive. So we would say no, because those 2 things can both happen. You can wake up late and get to class on time. Kind of depends a little bit on what you define as waking up late. If you wake up after the time class starts, then no, but those would be mutually exclusive. But if waking up late just means waking up later than your original time, the normal time for you to get up, you could wake up late, skip breakfast, still get to class on time. Okay, addition rule of probability. The probability of event A or event B or both occurring is given by the probability of A union B, A or B, we see that here, is the probability of A plus the probability of B minus the probability of both. We subtract the probability of both because we counted it twice. Probability of A is here, the probability of B is here, and it has this place where they overlap. So we subtract it once so that we don't count it twice. Otherwise, you're counting it twice. Okay, so this is kind of a demonstration of what we're talking about. The probability of A includes this part right here. The probability of B includes this part right here, probability A and B. So we have to take out this part once so that we're not counting it twice. Just repeating myself now. Therefore, we get the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. All right, give your answers as fractions and decimals and percentages. All right, so what's the probability of A union B if probability of A is 0.37? So we've got the probability of A plus the probability of B minus the probability of A and B. So the probability of A, 0.37. Probability of B is 0.45. And the probability of A and B is 0.17. So if we just add those events together, or add those quantities together, we got 0.37, just plugging this into my calculator, plus 0.45 minus 0.17. And that comes out to 0.65. And you can convert that to a fraction, 65 hundredths, and then simplify it. That simplifies to 13 twentieths. And then as a percentage, that would be 65%. Okay, probability of A union B, if the probability of A is 4/7, probability of B is 10/21, and the probability of A and B is 4/21. So once again, it's just 4/7 plus 10/21 minus 4/21. and you can put that in your calculator. So just make sure you write each fraction in a set of parentheses. So 4 divided by 7 plus 10 divided by 21 minus 4 divided by 21. And I hit enter, and it gives me a decimal. So on these calculators, if you type in math, enter math right here. Math, enter, it converts it back into a fraction in simplest form, which in this case is 6/7. And that is approximately equal to 0.86. And that's approximately equal to 86%. Okay, what is the probability of fair 12-sided die is rolled? Find each of the following probabilities. So what's the probability of less than 4? Give me just a second here. Okay, it's useful to sometimes list out your sample space. It's not always practical, but it is useful. In this case, we're looking for the probability of less than 4, less than 4 or a multiple of 5. And so less than 4 are the numbers 1, 2, and 3. 4 is not less than 4. If it had a little equal sign underneath it, then 4 would be included. But since it just says less than 4, it's just numbers 1, 2, and 3. Multiple of 5 would be 5 times 1 is 5, and 5 times 2, 10. So here you can see that the probability of those two things happening are 1, 2, 3, 4, 5. That's 5 out of 12. And there's not a number that is both of these, both less than 4 and a multiple of 5. And so that part where we say it's the probability of A plus the probability of B minus the probability of both, there's not a number that fits in that category that's both, because 5 is bigger than 4. And so is 10, and so is every other multiple of 5. So 5 out of 12, and 5 divided by 12 is approximately 0.42, which again then would be approximately 42%. If we look at the probability of greater than or equal to 7, greater than or equal to 7 would be those numbers there, or odd. And so odd numbers would be 1, 3, 5, 7, 9, and 11. And so here you can think of the probability of A. Oops, let's write this color here. It's odd. The probability of A is 1, 2, 3, 4, 5, 6 numbers that are greater than or equal to 7. Probability of, let's say, greater than or equal to 7, and that's once again 1, 2, 3, 4, 5, 6. So that's 6/12 plus the probability of odd, and that's 1, 2, 3, 4, 5, 6 numbers. So that's again 6/12 minus the probability of both. And so that'd be minus the numbers that are both greater than or equal to 7 and odd are 1, 2, 3. And so that'd be 3/12. So 6/12 plus 6/12 would be 12/12 minus 3 would be 9. So we've got 9/12. That simplifies to 3/4, 0.75, or 75%. All right, let's take a look at the next one. Probability of even union prime, or we can also say even or prime. Let's mark this again. Even this time we'll use green, and we'll say that's 2, 4, 6, 8, 10, 12. Prime. Now the prime numbers are 2, 3, 5, 7, and 11. So the probability of even plus the probability of prime minus the probability of both of those things. So we've got probability of prime here in blue, the probability of even here in green. Two is the only even prime number. But the probability of even, we've got 1, 2, 3, 4, 5, 6 out of a possible sample space of 12, plus the probability of prime, which is 1, 2, 3, 4, 5 out of 12, minus the probability of both, and it appears there's only one number that is both, and so that would be minus 1 out of 12. So we've got 6 plus 5 is 11, minus the 1 would be 10. 10/12 simplifies to 5/6, and 5/6, 5 divided by 6 is approximately 0.83, which again then would be approximately 83%. All right. Let's look at an example with the Venn diagram here. The number of students in the high school is 1,400. Of those students, 550 take French, 700 take algebra, and 400 take both French and algebra. So that's the one we can place. We can place 400 right here. We can't place the 550 for French because it includes those that take both, but we can place the one that both right in the middle. And so we go for French, 550 minus the 400 that take both would give us 150. Oops, sorry, that's French. 150 that take French only, that don't take algebra. Then we've got 700 that take algebra, so you take away the 400, that leaves 300 that take only algebra, because 300 plus 400 is the 700. And then we add those back together. 150 plus 400 plus 300, and that gives us 150 plus 400 plus 300, and that gives us 850. That's 850 students represented inside both of the two circles. If we then take 1,400, which is the total in the school, and subtract the 850, that gives us 550 outside of those circles. And so that's 550 right here, and they don't take either French or algebra. So it says fill in the Venn diagram, which we've done. Then find the probability that a student selected at random takes French or algebra. Remember, French or algebra includes everything in the one circle or the other. And it includes the space in between as well, the top. We've already calculated that with 850. So it's 850 favorable outcomes that either take French or algebra or both over 1400. If you put that in your calculator, 850 divide by 1400, enter. It gives you a decimal. If you take that decimal, this is approximately, so I'm going to say, wait, this is equal to, and then if I just hit math, enter, enter, it converts it to a simplest form, 17 out of 28. And that is approximately equal to the decimal that we found, which was 0.61, which then again is approximately equal to 61%. And so those are our answers. All right. I believe that's all we have for you today. So practice, practice, practice. You're going to do great.